Hi, I'm John. In this lesson, we will be discussing order and absolute value of real numbers. Let's look at our specific objectives. Our objectives are order on a number line, absolute value, and properties of absolute value. Let us look at a number line. In this example, we have negative pi, negative 1/3, the square root of 3, and 3 2/10. If on a number line a is to the left of a real number b, then we say a is less than b, or a is less than b. And if a is to the right of b, we say a is greater than b, or a is greater than b. On this number line, we say that negative pi is less than negative 1/3, because negative pi is to the left of negative 1/3. So negative pi is less than negative 1/3. 3 2/10 is greater than the square root of 3 because it's located to the right. And we'd write 3 2/10 is greater than the square root of 3. Let us look at an example. Write the numbers on the list in numerical order from smallest to largest and use the calculator if necessary. First, we will write them in decimal form, rounding them off to the nearest tenth. Square root of 8 is about 2 8/10. Negative 4 is fine. The square root of 3 is about negative 1 7/10. Negative 2 is fine. Negative 5 is fine. And the square root of 6 is about 2 4/10. And then we have 3. And now we can order them. Our smallest number is negative 5. Our next number is negative 4. Then comes negative 2. Negative 1.7, then 2.4, 2.8, and then 3. And then go back to our original numbers, which was negative 5, negative 4, negative 2, minus the square root of 3, the square root of 6, the square root of 8, and 3. The following symbols are variations on the greater than and less than symbol. We have less than or equal to, we have greater than or equal to, we have not less than, and we have not greater than. You can write 8 is greater than or equal to 6 because, in fact, 8 is greater than 6. And you can write the inequality 7 is less than 8 is less than 9, where 8 is between 7 and 9, or 7 is less than 8, and 8 is less than 9. Let us continue the lesson by talking about absolute value. The distance on a number line from 0 to a number is called the absolute value of that number. It is written in red, the absolute value of a. The absolute value of 5 is 5. And the absolute value of negative 5 is 5 because 5 and negative 5 are each 5 units from 0. Negative 5 is 5 units from 0, and positive 5 is 5 units from 0. Let's take a look at an example. Let's evaluate each expression. The absolute value of negative 5/8. That is equal to 5/8 because negative 5/8 is 5/8 units from 0. B, the negative of the absolute value of 8. So this negative sign stays with us, and the absolute value of 8 is 8, and so my answer is negative 8. Here we have the negative of the absolute value of negative 2. Well, this will be the negative of this value, which is 2, or simply negative 2. The absolute value of 2x, if x equals pi, absolute value of 2x will be the absolute value of 2 pi, and since pi is a number greater than 0, we simply get 2 pi. There's an algebraic definition of absolute value. Let's look at it. For all real numbers a, the absolute value of a is equal to a if a is greater than or equal to 0, and it's equal to negative a if a is less than 0. Let's try an example. Write the expression without absolute value bars. We want to evaluate the absolute value of 2k minus 8 if k is less than 4? Well, if k is less than 4, 2k minus 8 will be less than 0. So going back to our definition, 2k minus 8, since this will be negative, will equal to the negative of 2k minus 8. And that will be negative 2k plus 8, or the absolute value of 2k minus 8 can be written as 8 minus 2k. There are some properties of absolute value that you should be able to use. Let's look at these properties now. For all real numbers a and b, the absolute value of a is greater than or equal to 0. And the absolute value of negative a is the same as the absolute value of a. The absolute value of a times the absolute value of b is equal to the absolute value of the product of a and b. And the quotient of absolute values, the absolute value of a divided by the absolute value of b, is equal to the absolute value of the quotient of a divided by b, of course, providing b is not equal to 0. And the triangular inequality, the absolute value of the sum of a and b will always be less than or equal to the sum of the absolute value of a and b. Let's look at an example using some of the properties we just talked about. Use the information below to illustrate that property 5, the triangle property, of this following absolute value. Find the absolute value of a plus b, for a is 3 and b is minus 7. So we're going to look at the absolute value of 3 and a negative 7. And we're also going to look at the absolute value of 3 and the absolute value of negative 7. On this side, this becomes the absolute value of negative 4. And over here, this is 3, and this is absolute value of negative 7 is 7. Here I have 4, and here I have 10. Now 4 is in fact less than or equal to 10, so the absolute value of a plus b is in fact less than the absolute value of a plus the absolute value of b. Now it's time for you to try a problem. Pause the video and work out the following problem, and then restart the video to check your work. Use the information below to illustrate property 5 of the absolute value. Find the absolute value of a plus b when a is 2 and b is 12. Let's see how you did. Again, we are going to look at the absolute value of the sum, 2 and 12, and compare that with the absolute value of the individual parts, the absolute value of 2 plus the absolute value of 12. On the left side, this is the absolute value of 14. On the right side, this is 2, and this is 12. On the left side, this is 14, and on the right side, it is 14, and they are equal, and so it upholds our triangle inequality, and since 14 is in fact less than or equal to 14, since it is equal. Now, when evaluating absolute value, you must remember to follow the order of operations. Let's try an example. Let x equal negative 6 and y equal 10, and evaluate the following expression. 2 times the absolute value of x minus the absolute value of 3y divided by the absolute value of the product xy. So we'll make our substitutions. We're going to have 2 times the absolute value of x, which is a negative 6, minus the absolute value of 3 times y, which is 10. We're going to divide this by the absolute value of x, which is negative 6, times y, which is 10. For our first step, we can take the absolute value of negative 6, which is 6, so we end up with 2 times 6, minus, and we have to evaluate the inside here first. We're going to have the absolute value of 30, dividing by, have to do the inside first. We're going to have the absolute value of minus 60. Continuing along, 2 times 6 is 12. We're going to have subtract the absolute value of 30, which is 30, And the denominator, the absolute value of negative 60, is 60. Simplifying further, absolute value of 12 minus 30 is minus 18, divided by 60. And both of these are divisible by 6, so I get minus 3/10 for an answer. Absolute value is also used to find the distance between 2 points on a number line. Let's look at an example. Find the distance between negative 5 and 8. So we want the absolute value, since we want a distance between 8 and negative 5. So we have to do the inside first. So this will be 8 and 5, the absolute value of that, or the absolute value of 13, which is 13. By looking at them in the other direction, if I look at the distance from minus 5, subtracting 8, I will now get the absolute value of negative 13, which is 13. In this lesson, we've looked at the order of real numbers and absolute value. Be sure to practice plenty of problems in your text to reinforce these knowledge.